morning, everyone. This is Julie McDonald with Microcom Technologies, and I'd like to thank all of you for attending today's webinar with PoE Texas. Today's host is Tyler Andrews. He is their CEO, and he will be presenting today. If anyone has any questions, please submit them in the question box, and Tyler will answer them at the end of today's presentation. Tyler, I am finished for now. Thank you so much for being with us today. So I am ready to give you the floor. Go ahead and take it on over.
Well, great, Julie. Thank you for that introduction and giving us another opportunity to discuss Power over Ethernet with your audience. If you haven't seen our previous presentations or webinars, I recommend going back to watch them about the fundamentals of Power over Ethernet, what's happening on right now, and I'll add it up here, the Specifier's Guide to Power over Ethernet. So go back and watch those if you haven't seen them yet. Today, we're going in a totally different direction. We're breaking barriers. So how many times has this happened to you? You're pulling a device only to find the route you've been given is longer than 330 feet. Or worse yet, you've got all your cables in, the walls are all covered up, and there's no way you're getting anything else into that wall. And the customer appears out of nowhere telling you he just has to have one more thing on the network. That didn't go well. Well, today I'm going to show you 3 PoE products and how they work to give you a flawless victory. Today, we break the 330-foot Ethernet barrier by introducing Power over Ethernet extenders, how you pick them, and what they do for you. Best of all, you can find all of these products right here on microcom.us. So our first product tackles the situation when you need just a little bit further with your data run. And I'm going to give some details, a little background here so you understand why. If you're like me, and many other people, you get a sense of betrayal the first time you discover that the world-spanning internet you come to see in your computer can only travel 100 meters or 330 feet on Ethernet cable. You ask yourself, really? 300 or so feet, is that as far as you can get? Now, your job is in just that much harder because you don't have 330 feet. You have like 350 or 500 feet. Fortunately, the real answer to that question is just to extend the data signal. It's really the data signal that limits to 330 feet. So I'm going to give a little bit of an explanation. And to do that, I'm going to get physical. Hashtag engineering joke. And they're going to keep coming, by the way. First, the Ethernet physical layer, in plain English, how we actually send signals over copper wire, really fast pulses of plus 2.5 volts and minus 2.5 volts of electricity. When the volts are high, 2.5 volts, we call it a 1. When the volts are low, minus 2.5 volts, we call it a 0. And thus, a bit of binary is born. Ah, the magic of logic. And boys and girls, when a 1 and a 0 get together and love each other very much, 8 times to be exact, we call it a byte. Our ideal world of 1s and 0s is ruined, though, because even the best wires in the world have some resistance. What starts out in the beginning as 2.5 volts wears away as it trudges down the copper wires of category cable. Eventually, the electrons have gotten so tired they stop being excited at all. We can all blame Georg Simon Ohm for this. He's the one who came up with Ohm's law. It's his fault that this works. To help us manage that disappointment, our good friends at IEEE, and I'm pronouncing it right if you remember from the previous presentations, set a standard that as long as you're on Cat5 or higher cable, your network device has to at least send and receive signals that can travel 100 meters or 330 feet. So that's all we do. Now, I know, from my detail-oriented friends out there, yes, of course, some brave souls, us included, have made specialized switches and cables that can go further than the minimum 330 feet. But like all good standardized testing situations, if you can just do the minimum, why wouldn't you? So 90% of the time, you're stuck at 330 feet. Now, all very interesting. I've given a really fun story here, right? But what has Power over Ethernet got to do with how far Ethernet signals can travel? Well, I'm so glad you asked. Remember that measly plus 2.5 and minus 2.5 volt signal? Well, with Power over Ethernet, that signal gets to ride on a supercharged tsunami power of 56 volts. I'll bring that up here. Much like a real tsunami, that wave can travel much, much further. Yes, the 2.5 volt signal still tuckers out at about 100 meters, but we can use that tsunami of power to create a truck stop where the 2.5 volt signal can get out, get a shot of caffeine, stretch its legs, and head out for another 100 meters. Then, when it gets tired again, we boost the signal again. Rinse and repeat until the 56 volts goes too far to keep powering devices. Now, how far is that? Depend on what you're powering at the other end, it's almost a kilometer. And all of our devices, like the Gpue extender, have a table explaining how far you can take that device. And that truck stop is, like I talked about, the Gpoe extender. So I'm going to let my good friend Maria show you a Gpue extender and how it works.
Watt single port 802.3 BT injector. The Gpoe extender version 2 is designed for exterior applications with an IP67 rated aluminum alloy, mounting tabs, and weatherproof RJ45 jackets on both the input and output ends. To get your cable connected, start by unscrewing the ends and removing the rubber jackets. Here, I'm simply bringing in the data to the injector. Now let's connect it. As noted on the screen, the extender should be placed at 328 feet in your run. These jackets do not come pre-cut, but it does make for an easy cable connection. Now we can connect the 55 volts to the input end of the extender to power it on and re-secure the protective jackets. Before connecting it to your end device, simply follow the previous step to protect and secure your cable. With our simulated PoE device, you will see that the Gpue extender is working to send power and data beyond the standard 100-meter threshold. The Gpue extender is 802.3 AF, AT, and BT compatible, and is also designed to be PoE powered so that you will not need an external power supply to use it. It's IP67 rated as well, with 6 kV surge protection, and comes with a temperature rating of -40 to 65 degrees Celsius. It is auto-negotiating to comply with the PoE AF, AT, and BT standard, and supports gigabit data rates.
So now that you've gotten a picture of the Gpue extender, let's talk about that other situation that I told you about, where you need to add more devices where you can't fit in any more cables. That's where these next two devices come into play. We'll show you our PoE Plus device with USB charging port plus PoE. Let me bring that one up.
Same, we're just going to swap out the end wall unit that we use.
This one is going to feature our GAT USB IW, a PoE plus to 5-volt 12-watt USB charging station with an additional port for output 802.3 AF PoE. Let's jump right in.
For more details on which instruments we used, cable fishing, and pinning out your own Ethernet cable, please go back and watch our video on how to run a PoE jack. Since the process is the same, I'm going to just review some of the key installation notes. My first step is to measure how high I want this PoE jack to be. The typical height for a wall jack like this is 12 to 18 inches. I measured out about 30 inches based on the design concept we have for this room. Now I'm ready to use the Dremel to cut out the space for the mounting bracket. Remember to wear your safety goggles. This isn't actually drywall that I'm penetrating, so it was a little easier to get through. If needed, you might have to go back over the corners like I did, just to make sure the opening clears out very easily. For this next step, I called in Tyler to help me out. I didn't feel super comfortable drilling through 2 studs while on this ladder, so I called him in as backup. What he's doing here is drilling through the studs between the walls to create an opening to fish our cabling through. Once the openings are made, I prepare the cable to be fed through the wall. To do this, I took electrical tape and secured my cable to this pole or fishing rod. Once the cable has been fished down, reach your hand through and pull it out. Now that the cable is where I needed it, I secured the single gang bracket to the opening I previously cut out. This part was quick and easy. If the measurements are correct, it'll fit right in, and all you need to do is screw the tabs down to secure it. In our part 1 video, this is where we installed the GBT4 IW. If you want to see how that went, go back and watch the PoE jack install video on our channel. If you've already seen that, then keep on watching to see me replace it with the GAT USB IW. We'll start by removing the faceplate. There is a tab on one end to make it a little bit easier for removal. A helpful tip is to take a flathead screwdriver for leverage to pop it off. We want to replace this with the GAT USB IW to turn this jack into a charging station. The GAT USB IW is an in-wall PoE-powered USB charging station. Compatible with uplink 802.3 AT PoE, it delivers 5 volts, 12 watts of USB power, and has an additional output to deliver PoE for one 802.3 AF device. The PoE port supports up to gigabit data speeds, and the USB port works to fast charge Apple or Android devices. It's also active on the PoE port, so it will negotiate to protect non-PoE devices. On the front of this device, you will see a female RJ45 port and a female USB Type-A port. There's also an LED indicator for power and 2 mounting holes on top and bottom. The GAT USB IW also comes with a faceplate that snaps right on. Connect your Ethernet cable from your switch or injector into the uplink port on the back of the unit. Then push the cable back through the opening, position the unit in its place, and secure it with the included mounting screws. Once you pop on the faceplate, you should hear it click into place for a flat, flush-to-wall application. Now you have a PoE-powered charging station ready to use in your home or office.
Excellent. So that gives you PoE out and a USB charging station. So it makes a great extension for one device with an additional feature for an accessory, a USB accessory. Now, Maria had mentioned the 4-port PoE switch. So I'm going to also let you see Maria talk about that 4-port PoE switch.
Where your mounting bracket is. Instead of a network jack or outlet, I'm installing our GBT4 IW. This is an in-wall gigabit PoE extender switch with IEEE 802.3 BT uplink power. Simply bring in one cable run with 802.3 BT power into the uplink port, and you instantly have 4 ports of output PoE. With a 60-watt maximum output, you can power up to 4 802.3 AF devices or 2 802.3 AT devices. As you can see, it fits the size of a standard electrical outlet receptacle for a clean flush-to-wall installation.
Excellent. So you can see both of these devices really can come in handy when you're in a pinch and you have one wire and need to do multiple devices. So how about I throw out a few ideas here on how you could use them. You could use these with remote security cameras where wireless data just isn't reliable enough, adding additional VoIP phones without adding more cable drops, and turning an unused Ethernet port into a hotel room into a USB charging station that customers will use. So these are the different ways that you can learn to extend our data drops to your network without having to add more cables into the walls. When you're ready to learn more, we have live PoE experts right here in Austin, Texas to answer any questions you may have and help you pick the right solution for your product. You can reach us at, and I'll throw these up there, you can reach us at success@poetexas.com, and you can even talk to a real person by reaching out to us at 512-479-0317. We do look forward to talking with you. We do have real live experts in Austin that are happy to answer any questions you may have. With that, I'll remind you that you can find more on these topics in the Technical Center on our website, www.poetexas.com, on YouTube, or by speaking to your own PoE expert like I mentioned right here below. Now, as always, you can find these great products right here on Microcom. And with that, Julie, I'm going to turn it back over to you, thanking everyone for your time today and letting me introduce PoE extenders to you.
Tyler, thank you so much for that presentation. It was wonderful. I'm sure everyone enjoyed it. And meanwhile, yes, I do have some questions for you. Let's get started with the first one. It is possible that you may have answered these already, but let's just go through them. First one, does PoE Texas work with all third-party items?
That's a great question. We strive to work really hard to get universal compatibility. We are not a closed architecture. Now, having said that, there are edge cases, there are edge products that sometimes we have some compatibility issues with. One of the ones that is the most common one that people run into is the Cisco switches very often are reliant on Lldp negotiation for their PoE, unless you do a simple setting adjustment to allow for 2-event classification for anything over PoE+. But in terms of if your product says 802.3 or says PoE, IEEE 802.3 AT or IEEE 802.3 BT, yes, you should expect that these will be compatible. If you find any compatibility issues, you can speak with your PoE expert. We love to find out about those edge cases and get those solved for you. So these are intended to be universally compatible.
Thank you so much, Tyler. Next question for you. How far does each Gpoe extender run?
It adds an additional 330 feet or 100 meters. So if I have my PoE switch here, I can run 100 meters or 330 feet. I put an extender there. Then I get another 330 feet or 100 meters, and then I can put in another extender there and just keep going until you reach your power budget limit at the other end. The Gpoe extender is designed for 802.3 BT. It only uses about 3 to 5 watts of power at each step. And so what you do is you'll see it run out of power budget for whatever your device is. But if I'm using a PoE device, 12 watts, I can use a long series of those before I actually run out of power. If I explained that well, Julie, sorry.
No problem. Thank you so much. Next question here for you. Does the data connection have to be made with all of the device powers off?
That's a great question and an interesting question. No, the way PoE should work is PoE should allow your end device and your switch to both be powered on, and then it'll establish your data connection. So expect that your end device should start to power on, and then it's going to start negotiating a data profile with your switch. So you should not expect your PoE and your end device to be off while it's trying to negotiate the data. It should power on and then start negotiating. What happens with Lldp negotiation, which is what I was mentioning before, you would have to have your end device, your Wi-Fi access point or whatever device, power up in a low power mode state, then it gets some data going, then it tells the switch to send more power, the switch sends more power, and then it comes up to full power. So that may be the case that you're thinking about, but in the IEEE industry standard would be the switch allows you the full budget, your device comes up to full power and negotiates the data signal.
Thank you, Tyler, so much for that. Next question here for you. This may have already been answered in the video, but I'm going to ask you again. Are the jackets pre-cut?
That's a great question. They're not. Those little rubber jackets, they don't come pre-cut. You just need a sharp knife to cut them or a pair of sharp scissors, and then it'll open it up so you can just wrap it around your network cable. Technically speaking, if you're using unterminated cable, you don't even need that. You don't have to cut the rubber. You can just slide it onto the cable, and you first slide the metal ring onto it, then you slide the plastic housing, then the rubber, and then they stack up, and you terminate the Ethernet jack on the RJ45 jack on the head, plug it in, and then close it up. So cutting it is only required if you're trying to fit a pre-terminated cable through the rubber head or the rubber ring.
Thank you, Tyler, so much. Next question here for you. Does the extender work for indoor and outdoor cable or specific requirements in rating?
It works with indoor and outdoor cable. Now, having said that, if you're putting it outdoor, use outdoor cable. We've talked about this in some of our previous webinars. If you're going outdoor, indoor cable will break down outside in the presence of water and sunlight. So if you're going outside, definitely get outdoor cable, but if you're using it inside, you do not have to use outdoor cable. You can use indoor cable with the extenders and different devices indoors.
Thank you so much, Tyler. Next question here for you. What happens if you link more than 5 gigabit active PoE extender?
If you link 5 of them together, you're going to see that power I mentioned before. You'll see that power drop of about 5 watts per device. So if you start with a 30-watt power source, a PoE plus power source, after you add those 5 devices, your power budget is going to be really low. It's like a watt or 2. If you take and put it on an 802.3 BT switch that has 60 or 70 watts of power, you'll be down to like a PoE plus power budget at the other end when you connect 5 of them in series.
Thank you so much, Tyler. A couple more questions here. For the GAT USB, will there be an option to have a USB-C port soon?
Yes, fantastic question. And the answer is yes. It's in pre-production right now. We're rating it to be PoE++, so that you could connect laptops, you can connect larger devices, and it will do both power and data over the USB-C cable. So that's a great suggestion. We agree 110%. We currently do have a non-in-wall version that will, I'm trying to see if I've got my sample sitting on my desk handy, but it'll do 802.3 BT. It has a USB power and data port and 2 USB-A ports that connect to the USB-C host. So that's available today. You can find it on, and we'll get it on Microcom. It just came out, but you can also, we'll spin it into that in-wall device to here in the next 6 months or so.
Great, thank you. Last question here for you. Regarding the PoE Texas phone number that you posted that we could all see, is this number open for direct customer inquiries, or is this just for Microcom, for example, or can anyone call that number to ask questions and get help?
Anyone can call and ask questions and get help. Please let us know that you're calling from Microcom, because we love to support our Microcom customers. You can always call Microcom first and call us second, but this is definitely a hotline specifically for technical issues, problems with the device, finding out about where things are. It gets you to some PoE experts. So it's a hotline that anyone can use to learn more about our products.
Excellent. Thank you so much, Tyler, for answering all of those questions for us today. And also thank you to everyone attending today's webinar. And of course, just like Tyler says, if anyone has any further questions, please feel free to contact your sales rep here at Microcom or email us at sales@microcomtech.com. And if you wish to view any of the products mentioned or shown today, please visit us at www.microcom.us. And remember, this webinar presentation has been recorded and will be uploaded to our YouTube channel so that you can view it again. So it'll be out there forever for everyone. Tyler, thank you so much for being with us today. We appreciate your time and all of your incredible information that you shared with us. Everybody have a fantastic day. Thank you. Bye-bye, Tyler.